Alright guys, this is another video. This is on completing the square. So far we've only needed to factorize using integers, whole numbers. That falls down obviously when you have a quadratic that you can't factorize using any of the four methods we've gone over previously, because they rely on whole numbers. So if you looked at this quadratic formula here, that equation here, and you wanted to factorize the left hand side, highest common factor is not going to work because there's not a factor that goes into all three of those terms. Perfect squares are not going to work because there's not a perfect square to be seen there. Difference between two squares will not work, and sum and product rule, which is generally your go-to, won't work. There's no factors of -1 that you can times together will make -1, but also add together to make +6. So that falls down a little bit there. So there's another method to solve quadratic equations called completing the square, which you'd use for things like this. The steps involved are: 1. Rearrange the equation so the right hand side is a constant term. So you don't want it to equal 0 anymore. You would rearrange to get rid of this -1. That's the opposite of taking 1, adding 1, and so you would add 1 to both sides, and so it would be x squared plus 6x is equal to 1. So your first step is rearrange it so the right hand side is a constant term. Then you need to add a number to both sides of the equation to make the equation a perfect square situation. So obviously that add a number, that could be any number, but it's not that ridiculous. There is a way of working whatever this number is out. The number you add is half the coefficient of x and squared. So half the coefficient of x. The coefficient of x is the number in front of the x variable, not x squared, x. So 6 here, in that case, half of the coefficient of x is 3, because 6 divided by 2 is 3, and then square that. 3 times 3 is 9. So the number you would add to both sides for this particular equation would be 9. So there is a particular way to work out what number is to be added. It's not just any number. Then you would factorize left-hand side using perfect squares. The reason why it's called completing the square is this number that you're adding to both sides makes the equation a perfect square. So then you can factorize it using the perfect squares method, and then you would use the x squared is equal to k method to solve for x in this case. So let's have a look at this. Let's have a look at the example I used up above. X squared plus 6x take 1 is equal to 0. Now, step 1, rearrange the equation so the right hand side is a constant term. So, the constant term here is -1. The opposite of -1 is add 1, and we need to do that to both sides. So x squared plus 6x is now equal to 1. So we've made it equal a constant term. Step 2, add a number to both sides of the equation to form a perfect square. The number added is half the coefficient of x squared. So coef of x is equal to 6. Therefore, 6 over 2 is equal to 3. 3 squared is equal to 9. So applying that rule, I need to add 9 to both sides. So I'm going to do that in red. X squared plus 6x plus 9 equals 1 plus 9 to both sides, and that's going to complete the square. This is the completing the square step. So what will you end up with? X squared plus 6x plus 9 is equal to 1 plus 9, 10. And now that we've done that, this side can be factorized using perfect squares. 3 is a number that you can times by itself to get 9 here. 3 times by 3. And 3 is a number you can add to itself to get 6. So that's going to be x plus 3 squared is equal to 10. So I'm going to continue my working out there. So I factorize using perfect squares, step 3. Step 4, use x squared is equal to k to solve for x. Well, x plus 3, the opposite of squaring something is the square root. So it's going to be plus or minus the square root of 10. And then the opposite of adding 3 is taking 3. So it's going to be take 3 on both sides, negative 3 plus or minus the square root of 10. So what are your solutions? There's 2 there, it's written there as plus or minus square root of 10. That's can be written as plus the square root of 10 or negative 3 take square root of 10. This means the same thing, okay? So that is the first example. That's a solution for that there. Let's run a different example. Let's apply those same rules to, hopefully this is a more complicated one. So x squared take 6x take 13 equals 0. I need to make it equal a constant. So x squared takes 6x. Opposite of taking 13 is adding 13. So it's going to be x squared take 6x is equal to 13. I need to add a number to both sides, that is half of the coefficient of x squared. Co-f of x is equal to negative 6. Negative 6 on 2 is equal to negative 3. Negative 3 squared is equal to 9. So in this case, I again add 9. So it's going to be x squared take 6x add 9 is equal to 13. Add 9 again. So x squared take 6x plus 9 is equal to, what's 13 plus 9? 22. And now we use perfect squares to factorize this side. Negative 3 times by negative 3 makes positive 9. Negative 3 plus negative 3 makes negative 6. So perfect squares. X take 3 squared. I've factorized the left hand side using perfect squares. It's x take 3 all squared. This time is equal to 22. Continue my working out over here. Opposite of squaring something is the square root. So it's going to be plus or minus the square root of 22. X is going to be, what's the opposite of taking 3? Adding 3. So it's going to be 3 plus or minus the square root of 22. So that is how you solve using completing the square method and then using perfect squares to factorize. Hopefully that helps you out, and I will see you on the next video.